Hey everyone, and welcome. Today we're tackling a Leetcode problem called divisible and non-divisible sums difference. It sounds a bit wordy, but don't worry, we'll break it down together, step by step. It's actually quite a neat little puzzle. So here's the deal. The problem gives us two positive whole numbers, let's call them and. Our mission is to find two other numbers. First, num1, which is the sum of all integers from 1 up to that are not divisible by second. Num2, which is the sum of all integers from 1 up to that are divisible by quote. Finally, we just need to return the result of num1 minus num2. Simple as that, conceptually. Let's walk through an example. Say is 10 and is 3. First, we find all numbers between 1 and 10 that are not divisible by 3. These are 1, 2, 4, 5, 7, 8, and 10. If we add them all up, num1 becomes 37. Next, we find all numbers between 1 and 10 that are divisible by 3. These are 3, 6, and 9. Adding them up gives us num2, which is 18. The problem asks for num1 minus num2, so that's 37 minus 18, which equals 19. And that's our answer. Okay, what's the first way we might think of solving this? Well, we can just go through each number, from 1 all the way up to. For every number we ask, is this number divisible by? If it's not, we add it to our running total for num1. If it is divisible by, we add it to the total for num2. Pretty straightforward, right? We just process each number individually. Here's how that looks in Python. We initialize two variables, num1 and num2, both to 0. Then, we loop with a variable from 1 up to. Inside the loop, we check if is perfectly divisible by. That's what I%m double equals 0 means. If it is, we add to num2, otherwise we add to num1. After checking all the numbers, we simply return num1 minus num2. So how fast is this traversal approach? Well, we have to look at each number from 1 to exactly once. So if gets bigger, the time it takes grows directly with, we call this big O of n, or order n time complexity. For space, we're just using a couple of variables to store our sums, num1 and num2. This doesn't change no matter how big is, so that's big O of 1, or space complexity. Pretty good. Now let's think, is there a cleverer, perhaps more mathematical way to solve this? Instead of adding numbers one by one? Yes, there is. Remember, we want to calculate num1 minus num2. We know that num1 is just the sum of all numbers from 1 to minus the sum of numbers that are divisible by, which is num2. So num1 equals total sum minus num2. If we substitute this into what we want, num1 minus num2 becomes total sum minus num2, and then minus num2 again. This simplifies to total sum minus 2 times num2. See, this looks promising. So to use this shortcut, we need two things. First, the sum of all numbers from 1 to. There's a classic formula for this. You multiply it by n plus 1, and then divide that whole result by 2. Second, we need num2, which is the sum of all numbers from 1 to blanks that are divisible by died. These numbers are multiples of like itself, then 2 times, then 3 times, and so on, up to some k times m that's less than or equal to. To find this sum, we first figure out is just divided by died, and we take the whole number part, often called the floor. This tells us how many such multiples exist. Then the sum of these multiples is times the sum of 1, 2, 3, up to, and that sum is times quote, 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 quote. So num2 is times k plus 1, all divided by 2. Alright, let's see this mathematical approach in Python code. First, we calculate the sum total. We multiply it by 4 plus 1, and then do an integer division by 2. Next, we find this is integer divided by tells us how many numbers up to are multiples of. Then, we calculate the sum of those numbers that are divisible by t. This is multiplied by t qua t plus 1, and then that whole product integer divided by 2. Let's call this sum divisible by m. Finally, using our shortcut, the result is the sum total minus 2 times this, sum divisible by m. No loops needed. And what about the speed and memory for this mathematical way? It's super fast. We're just doing a handful of calculations, a few multiplications, additions, and divisions. The time it takes doesn't depend on how big is. This is big O of 1, or constant time complexity, which is fantastic. And for space, just like before, we only use a few variables, so it's big O of 1 for space too. This is a very efficient solution. So let's quickly recap. We needed to find the difference between the sum of numbers not divisible by and the sum of numbers divisible by up to. The first approach, traversal, was straightforward. Just loop and check each number. This works in order n time, but the second, mathematical approach, was even cooler. By realizing that num1 minus num2 is the same as the total sum of numbers from 1 to n minus 2 times the sum of numbers divisible by m, we could use some neat formulas to get the answer in order 1 or constant time. That's a big win. Hope that breakdown made sense and helped you understand the problem and its solutions. If it did, please hit that like button. Consider subscribing for more Leetcode explanations, and feel free to drop a comment if you have any questions or thoughts. And hey, if you're feeling extra generous, there's always the Boba Fund. Keep practicing, keep coding, and I'll catch you in the next one.